So, good evening to everyone present here. A warm welcome to the third chapter of ProbeYond, our guest lecture series that brings us closer to the real world of technology and innovation. Today's session is special as it brings to our campus a scientist whose work shapes the nation's strategic capabilities and technological self-reliance. We are honored to welcome our chief guest, Mr. VSN Murthy Arikapalli, an outstanding scientist at DRDL Hyderabad, who has worked on key defense projects like BrahMos and ATGMs. For students of electronics, communications, and control, this interaction is a rare opportunity to see how concepts in signal processing, embedded systems, avionics, and optimal control can translate into real-time decisions in high-performance tactical missiles. As ProbeYond continues to bridge the gap between academia and industry, sessions like these remind us that our projects and our research can one day also contribute directly to national security and technological independence. So, with immense pleasure and respect, the Probe team extends a heartfelt welcome to you, sir, and to my fellow students who have joined us this evening. Let's listen keenly, question thoughtfully, and make the most of this interaction.
Can you hear me?
Yes, sir.
Yeah. Yeah. Thank you for the welcome address. First of all, I would like to thank Organization Committee, Pro, ECE Department, and Dean of NIT Trichy. And I also thank you profusely. And first thing is, I should congratulate for conducting these lecture series, which will immensely help you in getting insight into the various fields. Secondly, I should thank all of you and for giving me opportunity. And with that, I would like to give some small brief about. Yeah, yeah. Can you hear me? Hello. Can you hear me now?
Yes, sir. Yes, sir. You're audible.
Yeah, yeah. Somebody is.
Yes, sir. Yes.
Okay. With that, I will start our lecture. Actually, I don't want to uh, make your head heavy, so it's very light technical information and what is the technology development which is going on at present, and subsequently there is a denial because we are progressing well. Definitely, other countries do not like to us to become a developed country, so there will be technology denial. This happens everywhere, every time. And then what is the government initiative and the industry's responsibility and role? So the presentation consists of the evolution of technology. Especially, I have taken a case study of missiles because I work there, and also we'll be discussing about ISRO and BARC, which are very important. They play a very important role in nation building, development of missiles, technology denial, and subsequent government initiative and rise of industry and role of private sector. There are for immemorial years. We have been, people have been fighting. There are skirmishes, battles, wars at different levels. And you know very well from our epics, Mahabharata and Ramayana, that there are wars mainly fought for a piece of land or for a woman. This is very clear from our epics and also our history. You can see from, you can go through the history, this same reason for which they are fought. Uh, the recorded one was about 10,000 years ago in Eastern Africa, a resource rich. Basically, what you want basic amenities, water, food, and clothing, shelter, etc. etc. The needs keep growing. See, wherever there is a river, there is a civilization. You can very clearly see that. So, a resource rich and fertile lagoon known as Nataruk. This is the place where there was a first violent conflict was reported, and is brutal killing of 2 dozen men, women, and children. This is nothing as of today, but that time the population was so less, and it was a big information. The Nataruk massacre may have resulted from the attempt to seize resources, a territory, women, children, food stored in parts. That food was the most important commodity. Everybody requires it, whose value is similar to the food-producing agricultural societies, among whom violent attacks and settlement became part of life. This was reported by Cambridge University. Subsequently, there are many conflicts, fights between groups, battles between the regions and wars between the two countries, continents, etc. This we have been seeing it. Earlier it was fought for food or shelter or something else. Now they are fought between the countries for the territorial gains and the resources to gain the resources, access to the resources, etc. etc. This is what we have been seeing, like the Russia and Ukraine war, and the Israel and Palestine. And you can see a number of examples we can give. But this has maybe not a good example, but it has resulted into tremendous development, especially in the technology wise. 20th century has witnessed two wars among the World War and World War II. Uh, Millions of lives are lost. But at the same time, to win over the enemy, we have to uh, struggle hard and develop against the time, development the technology against the time to safeguard our own borders, and become today's necessity to defend the country's borders. Hence, the continuous development and improvements of weapon systems have taken place. The evolution of missiles. For hundreds of years, rockets were used basically to signal communication from one point to the other point, maybe for entertainment, etc. Now, subsequently, these are used as a weapon. The advancement of airplane technology paved the way for the guided missile development. This is during World War. And China deployed rockets. This is from the what we are seeing earlier signals indicating the signals, the crackers kind of thing, which was developed into rockets. And in 1232, to repel the Mongol besiegers at city called Peking. And subsequently, Korea developed the Sing-Jon. These are the rockets to to um, to safeguard their own borders. You can see the right hand side, there are the rockets, and subsequently the sinking John was further improved to attack the enemy using multiple warheads. This you can see with if you compare our epics, that one arrow is going into multiple number of arrows, are they are nothing but missiles. See, the basic first weapon, what you think is a stone, which is thrown for any to defend yourself when you fight with somebody. you take a stone and throw it. This is nothing but a projectile. So if you add propulsion to it, it will go further distance. If you add guidance to it, it will go to the correct target point. In India, these missiles initially developed by the first missiles were developed by Tipu Sultan. Tipu Sultan, perhaps the first ruler. This is what Rodam Narasimha, popular aerospace scientist, says, the father of modern rockets. And he has realized into four tech parks: Bangalore, Chitradurga, Srirangapatnam, and Bidanur. These are all called Taramandal pits. And the irony is the rockets developed by Tipu Sultan were used by British Army. Subsequently, in the World War, guided missiles were used. They are developed. The guidance systems are developed, and these are all used in the World War and for guiding the missiles. Airplanes was used to bombard the target using remote control. Uh, Rainy Loring is a person who has introduced the ramjet engine in 1913, which is a real breakthrough. And Robert Goddard, he's one more scientist which has developed the liquid propulsion system, which is we use extensively here in the rocketry. We also developed guidance and control systems. This is the most important milestone they have done, Germans, and this is the system which takes you to the right point or place or the target point. They had a program called Pen and Munde. This is where they have developed the missiles. And V1 surface to surface missiles are developed by these engineers, a group of engineers at this Pen and Munde, and tried out. There are other missiles like V1, V2. They are the missiles, next generation warfare for which they has been developed and to attack the enemy located hundreds of kilometers. This is what, as the rocket power increases, you can go to from a few hundred meters to kilometers to hundreds of kilometers. If you take classification of missiles, there are basically two types. They can be divided into strategic missiles and tactical missiles. The basic difference is the strategic missiles are they can be deployed, they can be fired for long range, they can be used for long range, and it consists of multiple stages: stage one, stage two, stage three kind of thing, and payload. And they'll be heavy and large in size, maybe meters in length, and mainly aimed at strategic targets like a bunker, a building, a area of destruction, which can destroy a complete town, a village, or city, kind of thing. They can carry conventional warheads or nuclear warheads, and they will use the navigation system. And this is basically characterized by the area of destruction, not point of target, point target. Whereas the tactical missiles, they are small in size, short and medium ranges they are used for, and they are of low weight, maybe a few kilograms to a few hundred kilograms, and they are they can be fired against a stationary target or a moving target, which is the very helpful. Like you can fire at a moving tanker, moving vehicle, or an aircraft or a ship. These are the various types of targets. Some of the targets can never be stationary, like a ship in water. It cannot be stationary, or an aircraft. Like they use seekers because they require high precision, and they have to hit the target point, which is very important. Otherwise, you will be hit. And they are highly accurate. They are not meant for area of destruction. Further, they can be defined or classified into air-to-air missiles, air-to-surface missiles. Air-to-surface means from the aircraft you are flying, firing at a stationary target on the ground or a moving target on the ground. Surface-to-air missiles, that is from the land to the aircraft. You can fire at aircraft. surface to surface missiles, that is from this point to the other point on the surface. From few hundred kilometers it will be traveling and going and hitting the target at some other place. These are some of the examples of these strategic missiles developed by various countries. And this is ICBM, intercontinental ballistic missiles. It will travel thousands of kilometers. And ship launched missiles, these are all the from ship you are firing against mostly against ship targets. That is a moving target, again slow moving target basically. And this can also travel about a few hundred kilometers. And air launched missiles from the aircraft. So from a missile, from aircraft, you fire. Aircraft is flying at high speed, maybe Mach or 2 Machs, and firing against a target, which is again, it can be ground, it can be any other target. Then submarine launched vehicle, that is you are firing from submarine and against basically a static target, that is a land or ship. These are all available on net. You can easily get it. Nothing secret about this. And similarly, the tactical missiles, Iron Dome. This Sam, this you must have heard of. Israeli war. This is very very much is coming in the news. And this is the launch of the air-to-air missiles from one of the aircraft. Basically, these are only some of the examples. And some of the other examples are very small. These are all fall under tactical missiles. These are all called man pads. And basically, these are all the carried by the soldiers. These are all so small, maybe 15, 16 kg of missiles, which will be carried by the Jawans, and from different terrains they can move on foot, and it can be put on the ground, it can be put on a tripod, or can be shoulder fired. These missiles can be carried and fired where a vehicle cannot move. And these are all very very useful nowadays. And these are all fired against various smaller targets, or even drones, against drones, some of the other tactical missiles. These are of specifications. These are all available from the net I have taken. These are all about 1200 is the length, which you can think of 1.2 meters, and diameter is about 120 Maybe weight can be 12 to 15 kg, and it can range. It can go to 3 kilometers, 4 kilometers, depending upon that, and depending upon the visibility, depending upon the type of target, etc. This, as you see from the picture, it can be fired from a person sitting on the ground and using a tripod, or it can be fired from the shoulder. There is a there is a sight through which he can spot the target. He can home on to the point at the target. He can the missile can be fired. I'll show you one video. This is about the man pads, where the soldier goes into the field, deploys the missile system, and fights. This is one of the spike missile systems developed by America. See how they are carrying it, how they spot it. There's a target. This is a night vision. This is a stationary target. The moving target. So this is the type of scenario where you can see the people carrying the weapon to the different fields. It's very very difficult in the actual scenario going to such kind of terrain, and you're having threat around you, and it's not easy to not to get detected, and but at the same time you have to find a target and hit the target, home on to the target, and that's very very crucial. And the missile also has to work in those conditions. It may be extreme cold or extreme um, uh, extremely hot temperatures, which is in fact our own deserts will go up to 52 degrees centigrade, and extreme, I mean, temperature also it will go into minus degree centigrade. So it's not easy to fight in those kind of situation, and the weapon also should perform perfectly in those uh, environmental conditions. Yeah, this is the missile configuration. Just briefly, I just want to introduce. A missile will have a one head and one tail. Tail will have the motor, where you can have a solid motor or liquid motor, which we have discussed now, till now. That can be that gives the initial thrust to the missile to push forward, and if you take it to the head, you can see the seeker. Seeker is nothing but radar. You must have studied it somewhere. Some people in ECE background, with ECE background, this seeker is nothing but a radar in smaller in size. Okay, where you the it can missile can see the target using, it's ice. They are like ice, and in between you'll have the control surfaces, where these are all used to direct the missile or change the orientation of the missile. And you have the electronics, where the processor, a navigation system, a telemetry system are put, where onboard system will capture the various the data given by other subsystems, and it will process, and the navigation system is the one which guides the system, the whole missile, to a particular point with respect to time. And the telemetry is the one which records the data, which is this is basically used during the preliminary operations, where you get the data back to the ground. You have a telemetry station on the ground which will get back the complete data to the ground, and will tell you where the whether the intended missile has gone to the intended point with respect to time, and any course correction is required. In some cases it can be done from the ground, some cases it's not possible. So it all depends on the type of the missile, type of the guidance, etc., given by as per the requirements. So to develop the system, it's not so easy, and it's very very tough. It takes years for the person, for the people or scientists to develop a system. Basically, you have to have the somebody has to define the system requirements, which is done by the user, Army, Navy, Air Force, or any other user. And we have to, as a customer, as a developer, you have to understand, capture all the requirements, understand with the personal interaction, etc., etc. And various documents are generated in the process. Okay, and what are the environmental conditions which it has to undergo, whether it should work in the cold conditions or saline conditions, or high temperature, or in the air. Suppose it's different for ships environment, and the army requirements are different. Suppose you are flying, put in an aircraft, the requirements are different. They are fired, they have to withstand the Mach number, that much speed, and the airframe has to should be able to withstand, and the extreme temperatures also it has to take care of. So conduct the preliminary design review (PDRs) with the participation of the customer prior to commencement of design or coding, and subsequently you have various milestones. CDR, it's called a critical design review, with the participation of the customer post completion of detailed design. And once the design is frozen, you fabricate, implementation, development of simulators for testing what you have developed, and the unit testing, system testing, acceptance testing. These are all you must have studied in your software engineering. These are all where this whatever you studied will be put to use. Basically, right from the system requirements, recording, analysis, etc., etc. These are all same as per the software model. Also, it will be same software development life cycle. You must have studied. Otherwise, you'll be studying maybe third year or fourth year. But this is very essential, and it is same whether it is hardware or software, more or less same with a little difference here and there. But as a system, you have to undergo the entire process, and this is actually and various standards are defined. If you are developing some systems, aerospace systems like ISRO and other things, you require as per the design should be as per the aerospace standards, and for defense military standards. And software, there is various standards. For hardware, standards are there. Where a mobile platform, there's a different types of standards are there. So these are all well defined. You have to follow, you have to design as per that. So this is what a brief information about your whatever engineering you're studying or studied will be put to use. So anything you learn during this 4 years will be very useful in the in subsequent your career development. Okay, this is one step. We have developed something or we are going to develop something. It's all fine. So when it has come to technology denial, what has happened to us? These are all three case studies I have taken. One is the ISRO development. So ISRO basically is, as you know, they develop satellites, they launch the satellites for a communication purpose and other requirements to meet the country's needs, right? So basically, we are denied with cryogenic engines. Cryogenic engine is very important, and they are very much required for development of heavy rockets and enabling missions like Chandrayaan, etc., etc. So they were, in fact, Russia has agreed, but US has objected, saying that, citing the MTCR, it's called Missile Technology Control Regime, which is says that it can be if it is not clamped, these cryogenic engines can be utilized for missiles of far distance reach. So with that, the whole program has been shut. Then actually, the what is the next step? The government has to look at our own development, our own research and development. So ISRO has taken as a challenge. Then they have earmarked some funds, etc. Oh, but the problem is that basically you're losing time and it requires a lot of effort, and there's a time loss and money also, a lot of money spent. So finally, in 2014, ISRO has successfully developed the cryogenic engines, and they are subsequently they are used for our satellite launches. This is one of the wonderful achievements by ISRO. And similarly, there is a navigation system which is called every country, every continent, they are having their own navigation systems. Like you must have heard of GPS. GPS everybody knows because of the mobile, and GPS by the American system, GLONASS by Russian system. Like that, there are various other systems by developed by China, Europe, and others. So, but we are heavily dependent on GPS or GLONASS. But the problem is this: we will be handicapped if somebody stops the this particular service, especially during the war. It has happened also. So we are helpless. We are handicapped. So with that lesson, we also said that we should develop our own system. With this is what ISRO has developed, the regional navigation satellite system, IRNSS. Now it's called NAVIC. Basically, this NAVIC gives you autonomy. You are not dependent on any other country in case of need. So these are the two major achievements Similarly, DRDO, Defense R&D Organization. Basically, DRDO makes missiles. In fact, they develop, they are into R&D of each and every system. Like you name tanks, they are there. Their shipbuilding, of course, they are not fully into it, but their aircraft development, yes, they are there. That they into lasers, they are into missiles, they are into different types of other weapons, they are into various systems which are all required, essential for the country to safeguard from your neighborhood. So this is what we have been doing and we will be doing it. But again, because of the embargo and sanctions, DRDO has to develop its own systems like fostering indigenous development and collaborating with academia and industry and promoting Make in India, etc. So one of the examples is directed energy weapons, which will be uh, can be effectively used against the drones. So basically, advanced defense technologies are denied to us. So, but it really has given us shown the path of self-reliance. So, how we have overcome is indigenous development, industry academia. This we'll talk about. Similarly, yeah, software and IT. And in essence, technology denial acts as a major hurdle, but DRDO strategy involves intense indigenous R&D and strategic partnership to overcome these limitations and achieve technology sovereignty. Similarly, bark, if you take, the bark is meant for developing the supercomputers, medical equipment, etc. They're all denied at the time of requirement when it is in need. So again, they have their own R&D team. They developed R&D team. They invested heavily in that, and they have developed the supercomputers, medical equipment, and advanced materials, which are very very important for various structural building like aircraft and other things, engines, etc. So basically, they are all imposed by embargoes and sanctions. So this anyway, it has given us good this thing of self-reliance. So this is these are all the three different cases we can think of. There are many main, but these are all the important organizations where they are like they are essential to the country's development. So what government has to do, what industry has to do in this case? Why industry? There is a requirement. So industry is the backbone of any nation building. Without industry, the country can't survive. And it drives the economic growth, creates jobs, fostering the innovation, and improves the living standards. As you see that right from your grandfather to your father to you, and the how the transformation has taken place and the standard of living, how it has gone up. By transforming raw materials into valuable goods, definitely they are transform the raw materials to goods and generates wealth. When you generate valuable goods, you sell it in the market, you make money, and this is put back into the industry, and the industry, the wealth will be created. And also you'll be earning the foreign exchange by exporting. Earlier we were importing, now we are exporting many systems, many items, and this will generate a lot of foreign currency. And modernizing other sectors like agriculture, obviously you have seen the kind of transformation agriculture has gone into earlier to today. And it also increases the national income and the stability of the country. Okay, you can be provided with good infrastructure, good amenities, and good roads, transportation. Everything will be improved. Building the infrastructure supports defense and provides essential services, all crucial for the nation's self-reliance development and global competitiveness. So industries, how they can go ahead? Industries can go ahead using collaborations with various agencies, countries, etc. Technology transfer (TOT) and memorandum of understanding (MOUs) signed with countries, with any agencies, including foreign countries. See, the product can be developed in many ways. There are various ways of doing it. See, one of these is build to print. Build to print is what it says is, let us say R&D agency, R&D unit develops a particular system. Now they want to see these R&D units. They don't get into production. Their job is to make develop a system or a product. So this product can be, it can be productionized. It can be, wherever they are having numbers. So build to print means I will give the complete design details, everything. I'll give the part list, everything I'll give it. Then some industry will take it up and they will produce it. That's the easiest and simplest way of doing it. The first step. And build to design. This is where I don't give the design details. I'll give only specifications. And I ask you to, using your experience and expertise, to build a system and prove it. This is one way of doing it. This is a bit, little bit next step, and which requires good kind of uh, mm, domain knowledge as well as technical expertise, and the system requirements and the system configuration. Basically, when you are given the specifications as per the system requirements, the configuration is built, and the PDR, preliminary design. This way, I think we already discussed detailed design. This is where the product development takes place. This is the way it has to go through. See, in order to, as I said, the government job is not to produce the items. There are industries which are to be set up. There are like public sector units also. You have it like HAL, Bell, BDL, etc. There are so many public, ECL. There are so many public sectors, BHEL. BHEL is not into defense, but there are so many other Bell, HAL. They're all defense systems which are all produced by them. So, but there also what happens is, they have their own limitations, and the some of the cases we have seen that these public sectors are also, they cannot take so many projects and produce it. That is one more problem we are facing it. And the even when we try to develop some vendors, we call it, or technology partners, we say that, industry partners we say. So basically we don't go to big PSUs because their overheads will be very high, and we try to develop locally some agencies who can really develop, and they have good technology, good skill, manpower, etc., where they'll be easy for us to for the access and development, and we can oversee the development also periodically. So there are so many other industries, small and big MSMEs also we call it, SMSE, MSMEs. They are all developed. Various industries are there. They are doing very well, extremely well, and so, but we have to, the government initiative is to develop these industries also. So basically, how do you do it? You have to collaborate with industry or academia. Academia is nothing but IITs, NITs, various prestigious institutes. So we have developed with academia, all IITs, we have Center of Excellence program, where some scientists are involved with the development of various particular systems, and they will be developed and passed on to various industries, and collaboration with industries also will be done. And we also give smaller orders to industries in order to develop the industry, and once they are developed and qualified, then they'll be entitled or qualified to get the production orders. Okay, so that way the industry also grows. Development come production partner, DCPP we call it. What do we do is, whenever we start the project, the industry is also involved right from the beginning, right from the specifications, and they'll be involved in the as a partner of that development program. And as their views are taken, then they'll be continuously involved in the development. They'll be overseeing the development. They'll be involved. They'll be getting the hands-on experience in the development, and the product is developed from the starting point to the final product phase. So this way, they're all trained well, and they know all the difficulties, what are the criticality, what is the criticality in the system development, and in that process they learn a lot, and subsequently production orders can be placed. Suppose one example is, if you are talking about a tactical missiles, which I have discussed about. Tactical missiles, we require numbers, huge numbers, maybe thousands. So this can be developed with the industry partners who can be, who are involved during the product development, and easily they can take over for the production of these articles. Then technology transfer. Technology transfer is very similar to we develop the technology, we transfer it to some industry, and they will take over. Then we'll give the technical support and throughout the development, throughout the production, and after that life cycle also. And production orders, as I told you, subsequently, whenever they were once they are trained, they are ready for the taking up the orders, and well qualified, well trained, manpower is well trained, then production orders, whenever they follow, they can be the, these are the people who are given the preference, who are given preference for the production, getting the production orders. Hand holding is like right from the development to production. In fact, suppose if you take unlike our commercial products, these defense products, their life cycle will be very high. Initially 15 years, 20 years, 25 years, something like that. We have to keep extending it depending upon the product quality. There are various methods to do that. So this hand holding is required. This can't be done by the production unit because they are having their own difficulties in taking the decisions and modifying it, which they are not entitled to do it. As a designer, the designer will come forward and will help you in doing the any modifications, life cycle extension, or any enhancements, or as per the user requirements. The same product can be improvised over a period of time. Like that, these are all the various ways the government or agencies can really help the industry. Technology Development Fund is one more way of doing it. Like the government is ready to fund it up to certain amount, few crores, to um, fund your ideas. You give an idea, you take up that you can apply for the fund, and you can try to develop it, and they, of course the government agencies will oversee that, and they'll be helping you if required wherever you are stuck, and in that process you develop a product. So subsequently you can get the production order. So these are all the various methods as per the government thing, and to develop the industry like that. And right now I am representing Anant Technologies. Anant Technologies is one of the MSMEs falls under, and it is into the development and production of defense products, onboard systems we call it, that is missile subsystems, various missile subsystems they develop, and also they work heavily for ISRO. ISRO subsystems, satellite making, and launcher integration, satellite integration, and they do a lot of work for ISRO also. These are the various onboard subsystems. They look very rugged. They are designed and to be qualified. They're all qualified. And what I'm saying is they are to be qualified to withstand various harsh environmental conditions, which is not easy. So actually the qualification time itself takes about 2 months for a smaller subsystem. So that, and if it fails, again the cycle, it goes back, and it's if the design is not perfect, it will failure is certain. So you have to be very, very careful while designing it, and various standards to be followed, environmental conditions to be as per that you should be qualified. These are all the various onboard computers and navigation systems. They are similar to it. This is the system developed for ISRO, this clean room. where this satellite integration is going on. This is the first and only private agency, Anand Technologies, which is been qualified for doing the integration of satellites and launches. And the person who is facing in the picture is Dr. Subbarao Pauluri. He is the Anand Technologies CEO, and he is ex-ISRO scientist. Then he has set up Anand Technologies in Hyderabad. They have now the offices in Bangalore. This is the Bangalore office for satellite integration, and Trivandrum for the launcher integration. We have Hyderabad office where all defense related subsystems are being developed and produced. So the conclusion, as per this is we have started with imports. We are heavily dependent on imports, like all the ships we have taken, all the tanks we have taken, all the aircraft we have purchased, you name it. So even satellites are launched from some other launcher outside the country, like that. Now, when we started the development, then technology denial. This we have seen it. Then indigenous development, the initiative given by the government agencies and collaboration with industry and academia. We also collaborated with IITs, various IITs and industries, big industries sometimes, even L&T, Godrej, and like that. Then self-reliance in the process when the technology is denied. This is one way it's good for us. We are not dependent on anybody. Maybe we are a little late, but we have achieved self-reliance through that, and we also saved a lot of foreign currency. And we have also given technology to industries, and we have developed our own technology, our own infrastructure we have developed, and our own machinery we have developed, our skill we have developed by the personnel, our own personnel, which cannot be taken away by any foreign country. And whatever technology is absorbed by the agencies, government agencies, they are all passed to industries. Industries also in the process, they have learned, they have absorbed, they have gone to various other industries also. So now we are able to be self-reliant in some of the critical systems, and we are able to export the foreign countries, sorry, foreign nations. So we are able to export it to foreign countries. Like if you heard of that Sindur, there are a lot of talk about BrahMos and Akash, etc. These are the various missiles. They're all they got uh, good reputation, and various foreign countries are also showing interest in uh, for the purchase of these weapons. I think with this, I have finished my lecture. I think it's useful to you. This is a very light subject, light-hearted subject, and it's only for refreshing some of the interesting topics, and will be useful to you. Thank you very much. Any few questions? Anything you want to ask me? I'm available. Hello. Hello. Hello.
Does anyone in the audience have any questions?
Is it useful?
Yes, sir. It was very interesting.
No questions. We can close the session.
Okay, sir. As we come to the end of this enlightening session, it's a privilege to deliver the vote of thanks. So first and foremost, heartfelt gratitude to our chief guest, Mr. VSN Murthy Arikapalli. for graciously accepting our invitation, and for delivering this deeply insightful talk. Sir, your discussion was highly insightful. Thank you. Finally, a warm thank you to all the participants for your active presence, thoughtful questions, and bubbling enthusiasm. Such energy is what keeps these lectures meaningful, and we hope that today's session will inspire many of you. With that, on behalf of the entire Probe family, we'd like to extend our profound gratitude to Mr. Murthy for honoring this event, and we thank everyone for being such a wonderful audience. Thank you.
Thank you. Thank you very much for all the participants and the organizing committee and the faculty and the staff and ladies and gentlemen and the dean of the NIT. Thank you very much.